Hello and welcome on this first video in which I'll slowly teach you how to use JavaScript. I know there's a lot of videos already out there, but my videos will be focused on the new ES modules that came recently. And most online videos, they focus on the old JavaScript from before. So in this first course, we'll start by creating a Node.js project. So I'll make a different video on how to install Node.js. And for the purpose of this video, I'm gonna use the integrated Linux in WSL simply for ease. But all this information will also work on Windows. So let's create a project with npm init ESM to use these new modules. So it will ask, what will be our project? Let's call it course 1. Cannot contain capitals, version 1. We don't need a description. In ES modules, the files will be called mgs instead of just gs. There's no testing, no Git repository. If you have one, you can enter your name here. If you have a license, it will ask. Then, if you check the files, it will have created your index, your main. I've created a package. So if I open code, VS Code on that folder, now I'll use the integrated terminal for the rest of the course. We'll have this file, which is an old file that we don't actually need. And we have a main, which will be where we put everything. But for the purpose, we'll simply remove everything and rename main to index. If we have dependencies, everything will be added. We don't even need the ESM module for the new version. So index.mgs, in that file, we'll start with storing data. So let's say, what is your name? We'll say, my name is Jonathan, for example. So it's the same. Jonathan is a text. What does it belong to? It belongs in a variable that we can call name. So that's a name. Here it lets create your variable, but it also fact check that you don't put like the same variable later. If you do, it will just fail execution. In previous version of JavaScript before the ES modules, you could just type name equal and it created variables. You weren't sure where the variable was created, inside a function, outside. You could also use var, but var will let you. Technically, as you see, there's no red for an error. So let's stick with let. If it's something that's constant, like a version, you can also use const version equal 1. So what types of variable is there in JavaScript? So there's number variables, or at least data type numbers, which can contain decimal. There's text, which is between quotes. So this is my text. If you want to put a quote inside, you can just escape it. There's a lot of online information about escaping, and it might be a future video. You also have the Boolean values. So I can be true, I can be false. But as you see, in JavaScript, you don't type your variables. Your variable will just find its type from its value. It can change type during execution. There's arrays. An array is mainly it can contain multiple values. So 1, 2, 3, another 1, 2, 3, some text. An array will contain multiple values. And there, finally, there's objects. And objects is between brackets. And between brackets, it will work like variables. So you can consider an object like a complex variable. So we'll have on the left the it will be the name. You can use the text. So that object will contain, as you can see in the pop-up, it will contain both the name and the text. So when I want to use it, I could call objects dot name because it's inside. If I want to check, for example, the number, I could just use numbers. So for the purpose of it, I will use console.log, which is a function that will display information. So here, I'll call node with the name of my file, index.mgs. So the first log outputted the name from object.name, which got assigned to the variable. As you can see, if I re-affect the name, it doesn't change the value. And here you output what in number. You could always just directly output a value. So I want to show 1, 2, 3, 4. It's a number. It's easy. However, you cannot just have your code be fixed. It's what we call hard coding. It's something that cannot be changed. Okay, what if my name got changed in the future? I got married, my name changed. You want the value to have a container in which it is, and that container is the variable. There's also other data types that I haven't mentioned, which is basically undefined and null. So you can say, what is the type? Well, it's null. It's not existing. And what is the last name? Well, the last name is undefined. Undefined is basically a variable that never got created. Every variable out there will always be undefined until you give it a value. And null, it's you that specified clearly this doesn't exist. Now, if I want to log my object, if you look at the console below, you see it's a complex object with a name, text, type, and last name. What can you do with those variables? You can change them. Okay, so my number will now be 8. And I'll log numbers again. So the first time it got logged, it was that 12376. Then it was 8. The log command is still the same. So in programming, you can always change the value that is inside the variable. But you cannot change something like that 1234. So 1234 equal 123. What will it do? Invalid left sign assignment. You cannot, that's a constant value that cannot be modified. And if I want to change the version number, like my version equal to, it's the same. I'm assigning to a value that is constant. So my code will just fail simply because I'm trying to modify something that is constant, something that cannot be modified. But why would we want a constant? Mainly, let's say you have a big code, a Discord bot, or anything, and there's a text that you'll have to write 20 times. What if the name of the person change? Do you want to change it 20 place the code or one place? That's why we use constant values usually. Now, if we want to access the array, so let's continue with our logs. First, the array. It will show like I did with those brackets, those square brackets. You can then access it there with those brackets again, and you enter. The first value on the left is 0, then 1, then 2. And if you make a mistake, you access value 3. Well, there's only 3 value, so value 3 is outside. Well, it's undefined. Some programming language like Python, C Sharp, Java, they will throw an error. In JavaScript, it will just undefined. Okay, what about the object? Same. I can use name, but what if dynamically I don't know if I want the name, the text, the type, or the last name? Then I can access it by passing it another variable or another value in brackets. It is still get. So I could say, I want the name. So my object, the selector I want for my value will be assigned to name. Then I can copy the next thing. I want the text. Let's repeat. The first time I got my name. Second time I got my text with the exact same. So you can always use a variable inside the brackets to get the value from another complex variable. Then, if we want some structured data, what is this? It's just an object that contains. It's not clear. That's what we have classes. So what is a person? And we call a constructor. A constructor is a function. Functions will be defined further in the video. But basically functions are a part of the code that you can reuse later. So in this first place, a person has a name. This will assign to the current person we're working on. So let's say I have a name and I have an age, which start at 0. Now, that person, so let's call him Jack. We can create that class, so create an instance of person. So whatever you put inside those parentheses will go here in the parentheses of the constructor. For the purpose here, we don't need that. So let's just log what is Jack. So you'll see, it's still an object like we were previously, but it's also say it's a person. So when we have a structure that is repeated often, we can simply use a class to define it. And in libraries, you'll always see class. Discord JS is a lot of classes. A message is a class. A guild, which is a server in Discord, is a class. A member is a class. Everything is a class. So here on the right, you have the class. So the type of data you have. Then when you call the new function, you call the constructor of that class. And the value you get there is an instance. So an instance is like, okay, what is a car? A car has four wheels. So that's the class. If you say, my uncle's car, okay, that's one instance. It's one car out of all the possible car that have the same features. So Jack is an instance of person. Now, in that case, if I want to access just the name, you can always just jack.name. Same as we were, it works exactly like the object before. Except classes are a bit more complex. Now we'll go with the basic control flows that you'll need in your code. So do you always want the code to do the exact same thing, or do you want it to adapt? Well, a code is better when it adapts. So those Boolean values that are true or false are the basis of doing that. So let's start. I'll use n to consider a number, which will be 5. If we'll execute some code only if the condition returns true. Is my number more than 5? And everything inside those brackets will be executed. So let's say more than 5. Then, if it's not true, then we can use else. Less than 5. You can chain it with another if you prefer, if n under 5. So what do you think this will execute? N equal 5, if n over 5, if n under 5. Will it show more? Will it show less? Let's see. I'll let you 5 seconds to think. It showed nothing because it never went more than 5. It never went less than 5 because of the conditions. Then there we can also chain another else. And then equal to 5, which is where it goes. If you're neither more nor under, then you're equal. And let's see all possible like operators you can use for comparison. First, you can use under. You can use over. You can use under or equal. In that case, it will also contain the value. Over or equal. If you want to be exactly the value, then you can use double equal. Or in JavaScript, triple equal is valid and will also check it's the same type. Because in JavaScript, it's, we'll say, a bad practice, but you can compare directly like this. This will return true because it will try to see the value of the string. Oh, it's a number, so I convert it to a number. Compare, is 1 equal 1? The answer is true. But it's not the same type. One is a string, one is a number. in the end, if you do it like this, you might get some exception. So hence the tree equal. The tree equal would return false since this is not the same as this, even if they have the same meaning. But now, what if it's something more complex? Let's say, what if the number is between some values? So let's compare. I'll start with a value. Let's say the comparator, and we'll say 10. Then we have our minimum, which would be 5, and our maximum, which will be 15. Is our value between the min and the max? So we'll first check, and we'll need to include. So is my minimum under my comparator? Will that work? Well, it only checks the minimum, so we already have an issue, and the minimum should be included. So under or equal. Now we can use parentheses like we use in math. And we need something complex. So we'll say we also need, and also we can use the AND operator. Now let's compare. My comparator becomes left and my maximum become right. So my number must be both bigger than minimum and the maximum must be bigger than my number. If that's the case, then I'm in that range. Another type you can use is the OR. So either I'm bigger than minimum or I'm lower than maximum. So you know what that means? All values will be true. If you say 16, okay, is 16 higher than 5? True. Well, it's a binary table for the OR. As long as one is true, everything becomes true. And for AND, both need to be true. And you can chain, have more than that, have parentheses. Now let's see the basic math operator that you get. So you can use the plus to add numbers. You can use the minus. You can use the division. And you can use the multiplication. Everything else will be inside a math class that will need a separate video to describe. But let's see, what is the result of that? What do you expect? 1 plus 5, 1 plus 4, then 5. But here, with the priority of operation, 8 divided by 7, a little bit more than 1, multiplied by 2, so a little bit more than 2, plus the 5, so it should be just over 7. Right? Well, that's a minus, not a plus. So we'll take 5 and we'll remove just a little bit more than 2, and we got back to under 3. It's the same as the priority of operation you see in math. Now let's go for the functions. So a function The first type of function is a named function. The function A. What do you want with that function? I want to execute the code that will say a lot of A. If I run the code, nothing execute because I just created a function. So that code is behind that name. Then to execute it, I'll just call A. So I want A. I want A 3 times. Well, it will put 3 lines. Functions are that easy. But now we go back to the array we had before. It has multiple values, right? It has 3 values. What if I want to execute something on each of those? So we'll go with the first loop. This loop will say, I have a number, we'll call it z. Normally we call it I, but we already used I earlier, so we cannot. The first value is 0. The second value, the second part will be the condition. So I'm under the length of the array. So the length is how many? So it will return 3. And we say 3 is not a valid number. So we need to be under that value. The last part is what we'll do to a variable. Plus plus will increase that value by 1 every time. So the loop goes as follows. Okay, z equals 0. Do I satisfy the condition? And we'll call the A inside. I satisfy the condition, call A. Increase the value of z. So z is now 1. Is 1 under 3? Yes. Call A. Plus 1 is equal to. Is 2 under 3? Yes. Call A. 3. Check the condition. Is 3 under 3 false? Then I'm there at the end. That's the basic control array. Now, if I want to access the value, let's say I want to log what is in my array at the index z. So since that number increase, I will get that 1, 2, 3, 1, 2, 3, and the FD SAFG from earlier. Just by looping on the array. And that's really useful when you have both an array that you need the values and the numbers. However, you see, there's a lot of code, so there's a lot of possible errors. What you can also do for each value inside the array. So let's loop on value. And instead, we don't need the number. We don't need to know where it is. We just need what's the content. So we got that 1, 2, 3, 1, 2, 3, and the FDS, FG just there. In that case, even if you modify the value, it won't modify in the array. But here, you can just say every part. Then let's see something new. Plus equal. What do you think plus equal mean? Well, I'll write it in the long form. Plus equal is this. Programmers were tired of always repeating the value just to add one. So they just meant, okay, so if I knew plus equal, minus equal, divided equal, or any operators, I will just, that plus equal will take the current value and add, or take the current value and remove. So with those two, every value should be added by 2. So it will be 1 to 5, 1 to 5, and finally our text. But adding something to a text just concatenate the number at the end. Now we can compare if our value is over 1 to 4. It's an if we saw before. Let's say I don't want to process that information. What you can type is either continue or put every code you want in the else. It will mainly work the same way. Continue. What does it do? Is it finds the most closed loop and we'll basically skip every code, go back straight to that part where increase the index. And if that value, since it's a let of, you won't actually see that increment in the code. It will just do itself. So you go back to the first line with the next value. That's what continue does. And you can also put another condition, which will be, let's say, over 1 to 6. It's called break. Break. It terminates the loop. No matter if there's 10, 1,000 more values in the array, it will just end right there. No reason to continue. It breaks, it finds there at the end, and will just continue executing the code from there. That's break. Now that we have the loop, let's go back to the second type of function. So before we had the name function, but we want the arrow function. So our array, why would we always type a loop when we can just alter the array? So we'll call the map function on the array. That function takes a function. So the parenthesis from the function, then the arrow, and the brackets. The brackets are optional, but in this first example, we'll put them there. Now a function receives something in parentheses, so it will receive a value. And a function can return a value. So let's say my value plus 1. And we'll put that in an array named array2. That will log. So that function, for it's the same as you would write. For each value in the array, take that value, add 1 to the value, and let's get a new array that will contain that. So in the end, 1 to 6, 1 to 6, and a lot of numbers. Okay, another function that could help is filter. Filter, you need to return a condition, so a true or false. If my value is over 1 to 5, but there's a text in there. So let's see what's the output of it. Nothing. Well, my original array didn't have value over 1 to 5. So let's go with over or equal. Well, the text, when you're comparing a text to a number, it will usually return false, but it's really undefined. So filter, just take the value in which this return true. Now I said it's optional. So an improvement we can do is, let's say we remove the bracket, we'll also need to remove the word return. is basically a shorthand that does the same. So you can map the array, filter the array. There's a lot of other functions in the array. So if you use array.concat, copy entries, a lot of things for another video. But now we have functions, arrow functions that take a value, name function. Let's go with recursive function. I know I'm going fast. In a regular programming course, you will probably be at week 4 or 5 already. So that's good. Let's call a function. I'll call it R. And it takes a text. So what is the function R? If in my text I want to get that first letter. So if my first letter is A, I want to return true. Otherwise, and if you have only one line of text, those brackets become optional for loops and conditions like if. Only for functions, they're always needed. Unless it's an arrow function that immediately return a value. So we'll return our text R. We'll return the function on our text. And then we'll call splice. Or slice, it doesn't really matter. Slice will return the text, but starting at 1. So what we'll do is we'll log the text. So R is calling R. So we'll also log the result of our function R. For the text, this is a one. I forgot my brackets, my quotes. Wonderful experiment. Let's see. The result is true. But at first call, this is a wonderful experiment. Is a a wonderful experiment. Is, and it moved one letter until it was true. Now let's say it is a B wonderful experiment. Maximum call stack exceeded. Our function doesn't have an exit. Why? Because the text, when it reaches the end, is an empty text. So we can use and will never. It will always call itself for the same text. So what we can do is if our text dot length, like we used before, to check the length of an array. A string is basically an array, so you can use most of the function. So if it's 0, then false. If my text doesn't have a length, it can never be A, so I already know it's false. So it goes for the whole text until the end. In reach, oh, well, I don't have text anymore, false. So our function R will just check if the text contains the letter A, which is a capital A. So if you use lowercase a, it needs to be different. So that's what is a recursive function. Now, we'll finish this video with the concept of async. So let's say I have a code that takes a long time. So for that, we'll use the set timeout. So the set timeout takes a function and a number of milliseconds before execution. So if I do 1 second later, but just to make it simple, I'll go with 10 seconds. Console.log run. And let's go. Run 2. Do you expect run 10 seconds later run 2 or run 2 10 seconds later? Well, run 2. It waits, then it goes. Why do you think that? It's simply because that code doesn't block. So this will continue to execute, and this will just happen sometime in the future. And in JavaScript, that's a blessing and a nightmare. You can always execute only on the concept of one thread. One thing is executing at a time. So you cannot block anything. That makes, okay, I need run 2 to only show after that 10 seconds. It's basically what put at the end. How do you expect to do it if I cannot block the execution of future things? Well, that's what we call a promise. So we'll make a function. We'll call it wait. And there's an object in JavaScript that is called a promise. So we'll create a promise. Our promise takes a value that will be accept or reject. So it's basically it takes a function with two parameters, one to accept and one to reject. Now, what we can do is that set timeout. We'll use the parameter millisecond that we receive, and we'll accept the promise when it's completed. So we need to return the promises. Then, in the other function, I'll call an async function. You can always write it straight, but at the same time, let's learn async function. So an async function will be able to, let's run started. You'll be able to call await. And I want 10 seconds. Then I want that 10 seconds later and run ended. And let's call execute so it runs. So I got my run started. It didn't wait after the previous 10 seconds. But it also waited that whole 10 seconds. So that await is telling JavaScript, okay, I know we cannot block the thread. So I cannot just wait for the time to pass. I need to wait asynchronously. So let's run that code. And later in the future, when it completes, you'll be able to continue. That's the concept of the await. So that async function, if you look, it also returns a promise. So you can also chain with await and continue executing. So by making that function async, you already get the promise. You don't have to code with the accept, reject, the concept that we have here. It's implied. What is reject? Well, what if an errors occur? Like we had before, assigning the value to a constant, or that's a rejection. So in normal JavaScript, you can always try and catch. And you get the error here. So let's see. What I want to call, what will I want to call? I want to call that function R with a number. Then I'm gonna write in the error console the error. And I need to wait for the execution before it reach because of the await. Text.slice is not a function. That's an error because by passing a number, the slice doesn't exist. So that's why I went for slice and the R function. So it throws an error. So if I put here, I'll write 1, 2, 3. So this 1, 2, 3 will never appear for the reason that since this threw an error, it goes directly to the catch to write the error. But I think that error cannot be catched by try because it's a promise, it's in the future. So it goes to the reject. So if there the code could fail, the error will just go to the reject error. But there's no code here, so it cannot fail for now, but it will reject the promise. In an async function, a reject works with try and catch, since we have the word await. And if it throws, it's implicit that it will go to the reject of that promise that we never wrote ourselves. But since it's a promise, there's another way to do it. It's an object, so we can call it then. The then. I want, once I'm done, to execute that. Once done. But if it failed, I can just catch it. It failed. But that catch, that then also return a promise, so I can always await it. Now let's see. I want to get a value. So I'll create an async function, get value. But I want to get that value in the future. 1 second in the future. Then I return my value. So imagine that. But after that wait, we'll go with a mat.random to get a random number. If The random number, if you go in the description, it's a number between 0 and 1. Well, I want to throw an error. 50% of the time, I'll throw an error. Random error. What can you expect? With that, await. And I'll just remove the previous so we don't have to wait that long. Probably still have an await somewhere. That one. So now we get that once done. It never called it failed since it never failed. But let's see. I'll add comments. I'll comment that part to continue. So we have that value that has 50% chance of throwing an error. So we can get that value. And let's say I want to log that value that I got. Let's run. It's waiting 1 second. It worked. 1 second, it worked. My 50% there. It threw an error. The old program crashed. Well, because I don't have a try and catch. But what I can do is catch. If there's an error in my function, I can get the error. I want to return 0. It's simple. I get the value, so I have 50% chance of getting that 100, and 50% it will fail. If it will fail, it goes in the catch and returns 0 instead. So I got 100, 100, 100, 0. So that random got me after a few try. The catch here does two things. One, it catches the error so the program doesn't fail. Two, it provides a value that the code will be able to continue with since it requires a value. And that value is 0. So in the case there's an error, you get 0. With that, in the next video, we'll show how to use libraries that might get errors in them. And that will conclude the current video. Hope you liked it and see you next time.